All right. Let's see. Maybe I should put in the chat a link to the document. This so this the chat gets saved in the recording, right? Um, I hope. All right. Anyway, so basically there's this relationship. Basically, I think the most serious problem. Well, I mean, we have concerns, right? So we're forced to trade off between either having a priority level be specific to a workspace, in which case we have lots of priority levels potentially to deal with, or sharing or having a priority level span workspaces, which destroys some of the insulation between workspaces. Um, that's one big trade-off, and another one is if we want configuration specific to a workspace, and that requires objects that are specific to a workspace. Um, we can use, if we're willing to have the behavior be specific to a workspace, we can use the approach of having a default set of objects that are not stored, and then having additions and overrides stored. So that kind of mitigates that. Um, so anyway, um,
I have a question.
yeah.
Does it make sense to do option one, which is priority levels per workspace with the PLC and FS objects per workspace? Like, if that makes sense, and I'm going to defer to you in particular, Mike, like if that makes sense, I think we can find a way to make it happen. I just thought that it would be difficult to borrow between workspaces, or to put it another way, difficult to take the total maximum request that the server gets and somehow apportion or proportion that out.
So um, it makes sense. It's coherent in at least the sense that it's something you can define. It has that concern that we're talking about. So let me review. I'm sorry. Let me get a new cough drop and review the borrowing that we did just introduce that will appear in 1.26 between priority levels. So the way it works is configuration defines for each priority level a nominal concurrency shares, and then the servers, and this is upstream, so there's no workspaces, the server's total concurrency limit is divided amongst the priority levels in proportion to their nominal concurrency shares to get a nominal concurrency limit. But that's not the current concurrency limit that's enforced. There's a dynamically adjusted concurrency limit that gets enforced. And the way it works is every 10 seconds, there is an adjustment that takes into account the recent, I tend to say pressure, or I think in the CAP doc it's called seat demand. It's really looking at the number of seats so seat demand specifically is defined to be the number of seats that are occupied plus the number of seats in all the queued requests. And there's a subtlety also in APF in that a request has two different widths. There's an initial width and a final width. Um, and by width I mean number of seats. And so for this seat demand, we use the larger of the two because that's actually the way dispatching works. Dispatching also uses the larger of the two because unfortunately, when there's a difference, the larger width comes second, but you can't interrupt a request once you've dispatched it. So you have to dispatch conservatively. So anyway, that's seat demand. And the way it works is over the course of each adjustment period, between adjustments, uh, this technique keeps track of the average standard deviation and the high watermark of the seat demand. And then at and also each priority level is configured with a limit on how many seats it can lend and how many seats it can borrow. And these are expressed as fractions of its nominal. Actually, it's expressed in percentage, but anyway. Anyway, what the adjustment does is it's got a little bit of logic that's not quite trivial. You can see it in the cap, but basically what it says, the first thing it says is, or the effect is, first, any priority level that has lent seats for which demand has shown up in the last adjustment period will immediately reclaim those seats. And then beyond that, there's kind of a target that's defined as this gets smoothed. The thing there's exponential smoothing, and the input to the exponential smoothing is each period we take the average plus the standard deviation, and that goes into the exponential smoothing. But then if the high water mark ever jumps up, that immediately jumps that up. So anyway, the net result is that a level that has lent seats out of its nominal allocation will immediately reclaim them at the next adjustment. And beyond that, there's a kind of a attempt to share the pain or the wealth relative to the demand that's been seen. So I don't know if it's at all clear or understandable.
Yeah.
Is it, I guess, is it predicated on each priority class having some like non-fractional number of seats to give away in the first place?
So to be clear, regarding fractions, the way, even before borrowing, the way it worked is we would take the server's concurrency limit, and then for each priority level, it's got a number of shares, right, which is a fraction of the total shares. So you take that fraction of the total concurrency limit, which is in general not an integer, and round it up. And that gives the concurrency limit that gets enforced for that priority level.
I guess, okay, so we would see everything round up to 1, I guess.
If everything would nominally have kind of a small fraction, it gets rounded up to 1. Yes. So if we were to be concerned with a large number of workspaces and do this same kind of thing for workspaces, we would, you wouldn't get to 0 unless the fraction was actually 0, which you would basically never do because the exponential smoothing would never go to 0.
I guess also, if we have per logical cluster priority classes and the user has control over their own sharing methodology, I feel like we would not be, because there's kind of two audiences for PNF in KCP. The first being the KCP admin, the second one being an individual in a cluster. And I'm not sure that letting users configure their own priority classes and like lock people out of sharing would suffice for the admin case, right?
Yes. Okay, that's an interesting point, right? Normally in Kubernetes, we suppose, that a cluster has an admin or admins that are privileged and other users that aren't, and that's just end of story. But here you really got those two levels.
That kind of goes
Yeah.
back to what I was saying yesterday about we want to configure this for or as KCP operators. And our secondary goal is to maybe let users configure PNF for their needs within their workspaces, but that's really a distant second compared to the needs of the platform itself.
And I guess to maybe put some context there as well, like when you're using etcd as the backing store, like you have some really rough like concurrent mutation in flight limit type things before stuff goes to really unpleasant places. And so one of the thoughts very early on was we kind of know the scaling envelope that will make this reasonable. And it does look like quite a lot fewer mutating requests as compared to a normal kube cluster. But given that we don't have a bunch of reconcilers throwing status updates around, like, that's probably fine. And being able to somehow programmatically enforce that would be critical to ensure the stability of the system. But I wonder if we do a two-tiered approach, like, to your point about isolation between workspaces, inside of a workspace, if you configure APNF, like, for all you know, the server's max in flight requests is just a dynamic value. And like the number of requests that actually make it into your workspace in order to be handled by your own APNF, that's out of your control. And you would mostly be oblivious to the fact that there's a layer on top, right?
You being an owner of a workspace?
Yes. Sorry.
So if we were to do borrowing between workspaces, then clearly it's a dynamic value. And let me just add, another FYI. I'm not quite sure, what I'm still processing it, so I'm not quite sure what my final opinion is. But I'll just FYI, upstream, we do have, I was just told earlier this week about someone running into trouble with APF. And the scenario is they have, it didn't really explain why, but there was one client that was sending requests that always time out. And these were like big list requests. I think he was saying the client is slow to read the response. So each one of these requests occupies 10 seats because that's the maximum width. That's a limit in the code. And it takes a minute, it holds those 10 seats for a minute. And in the priority level that this was happening, the hand size was 6. So that means that this client could really occupy 60 seats at once, or was more or less ready to occupy 60 seats all the time. Because for each of the queues that this client is being dealt onto, every request holds on to 10 seats for a minute. And as soon as that timeout happens, there's another request waiting to take its place. Other requests could get in occasionally, but the concurrency limit applied to that priority level was less than 60, or maybe it was 60, but it wasn't greater than 60. So the other clients would have to wait basically for 6 minutes. I guess, well, he was saying that the concurrency limit was 10 or less. So really the other clients would have to wait for 10 requests from this bad client before another client would get served. So we talked about kind of guidance for configuration, and really the problem condition for this really is when the hand size times the maximum width is less than or equal to the concurrency limit, then one bad client can cause a lot of latency for other clients. So the guidance would be set the concurrency limit to be above the hand size times the maximum width. Now thinking about this in the KCP case, that puts a really non-small lower limit on the concurrency given to a workspace, or given to a priority level and thus a workspace. So, unless and until we can think of something better, and potentially we can, because this is kind of a special case that could maybe be recognized and dealt with other ways, but if we take that as guidance, I think that really shoots down the approach that says we're going to really have low concurrency limits for a workspace. So
Low.
that forces.
So is the implication there that having many priority classes that each get their evenly divisible set of seats is a bad approach because it'll run into this issue?
I'm not quite sure I'm going to follow what you said by get the evenly divisible number of seats.
So 1,000 requests in flight, 1,000 workspaces, each with 5 priority classes. Each priority class in each workspace gets 2/5 of a seat, right? Does that trigger the behavior you're talking about?
Well, as I was starting to explain earlier, there's ceilings gets applied. So every time um, the the logic, right, for deciding on the concurrency limits has a ceiling in it. So you never get a fraction of a seat. You always get 1 or 2 or 3, unless your shares were actually, or the total limit were actually 0. Then it could get 0. But that's not a situation that's going to happen here. So, see, unless we had, we have.
So,
a
I mean,
different
the
borrowing
2/5
between
runs up to
workspaces.
1, but is that
But my point here is that 1 isn't enough. Okay, right? If you've got a hand size, even if you only had a hand size of 1, the maximum width is fixed in the code at 10. So you would need really 10 seats in order to not have this problem.
right? I guess that's what I was getting at.
Okay, that's 10 seats in one priority level, in each priority level.
And so
So,
if, like,
however, I do want to say, kind of still in defense of this borrowing idea, right? We could potentially have a different kind of borrowing between workspaces, so that as I was saying, for borrowing between priority levels, we use this exponentially smooth um, uh, target or demand figure. And since it's exponentially smoothing, it'll never go to 0. For workspaces, we could tweak that so that it does go to 0, because obviously, we must be expecting, if you've got 1,000 workspaces, you must be expecting that most of them are completely idle. So we could adjust the borrowing so that it will give a 0 allocation to those workspaces. And what that would mean is that a request that arrives while the allocation is 0, sits in a queue until the next adjustment period, in which case that workspace would get, some multiple of 10 so that it can actually succeed, and then get dispatched. Now, I guess I should also point out, it's also possible, again, since today with APF turned off, we're just betting, hoping that there are not a bunch of requests that actually showed up at the same time. We could continue that, okay, and continue and just say that, yeah, okay, the minimum allocation per workspace is not going to be 0, and it will add up to a lot. But again, we continue to expect that most of it will be unused. I'm sorry, that a lot
we
of
already
workspaces will not use any of that.
We've spent significant amounts of time dealing with, unfortunately, chatty clients as it is. So
No,
I
no,
think that
I'm sorry.
assumption.
But to be clear, what I'm saying is the assumption is, the bet is that for most workspaces, they're completely idle. Not to say that some workspaces can have chatty clients, while still most of the workspaces are completely idle.
Hmm.
I hesitate to try and design under that assumption.
Right. It's making an assumption. I'd rather not assume.
Because I
Yeah.
mean, we've already seen like individual workspaces with like 200 mutating QPS, and it's not a good place.
Sure. Right. I understand. I mean, that's why we're here.
I guess the other thought is like, so just back to the straw man of invisible Uber APF, visible internal APF. In that duality, if it looks to the user in their logical cluster like they are virtually being given all of the mutate or all of the max in-flight requests, and the number of seats is calculated as if they were going to get all of it. None of the math is broken. It's just because there's another level above it, they just happen to never get very many at the same time. And I think that
I'm
ends
not
the
quite
happy
sure I
medium.
follow. I'm not quite sure I follow what you're suggesting.
So, two entirely disjoint systems of APF, one at a shard level, and then once a request goes through, I guess this would probably be a pretty invasive server change. But once the request goes through the first layer at the shard level, it can then be handled by APF in the logical cluster. That allows users to, give relative priority to their own workloads, but never exceed what the system gives their workspace.
I understand
I
what you're
see.
saying. I don't know how feasible it would be to implement because you're either processing everything twice or you're mapping
Yeah,
what
you'd have
looks
to.
like 100% of the shares or whatever
I think it's
to
twice, right? Basically, 2 layers of APF.
Yeah. I mean,
Yeah.
can we, I guess,
Mm.
trying to think about one ancillary design goal here is minimal massive changes to APF.
Right, and it's not clear to me that it would require massive changes to do 2 layers, right?
Right.
Really, what it's saying is that, where Jamie's got this delegator delegatee thing, right? That would still work for the second layer or inner layer,
Exactly.
right? And the outer layer, again, you would have one shared delegatee because it's really it's the controller, right? That consumes the config and manages requests. So because of the existing structure, um, the thing that handles requests, the controller logic is really modular, right? It's just got um, enough hooks to be able to delay or reject a request to then release it for processing. So it could just as well release it to the second layer of APF as to a following handler.
Yeah. I mean, that's basically my suggestion, right?
Yeah, interesting. I hadn't considered that.
and we could start with the system-wide one and then add the second layer later if we decided we wanted to.
So only have APF between workspaces. Yeah,
Yeah, like my primary concern is around being able to protect the system as a whole and not let users override system level protections that we would get with system-wide APNF.
okay. So
So
yes, right. So actually, right, this concern about users being able to destroy the protections is a new one. Also, I need to add that into this document. Um, and let me pursue another thing. I just wanted to understand, the concern in the other direction, right, is that without giving users control, they kind of don't have a lot of ability to customize, right? It's the administrator of the KCP server really has to configure it in a way that's going to work for all the workspaces.
yeah,
Yeah.
and if
It
you
seems
look
like
at
you'd basically end up treating every user workspace the same. And the user, like, because workspaces are cheap, it's easy enough to stamp them out. But I mean, from my understanding of Jamie's work, like, it's well positioned to solve both problems. And I don't know that, like, solving the global one first and then the user one second isn't like another year of effort, right? Like, it
yeah,
seems to me like that should, like, I don't know that we should. I think
No,
you're
well,
totally
and
right, Mike, and we could solve both.
he's already got the second layer. I mean,
Right.
it's working now. The only thing that's not there is the config producing controller, right? And if we go with the 2 layers, think about this now. I'm not sure I've really thought through the 2-layered approach. Um,
The only change that I might see us needing on the workspace side for the like user specified things is the actual like somehow making it opt-in, because more than doubling the footprint of each workspace is probably
yeah,
not
I mean,
needed.
my desire would be number one, that we install one copy of system level objects. And then if we go with letting users customize APF, they can optionally create their own flow schemas and priority levels in their own workspaces, but they're not required because it would always fall back to the system-wide ones.
And that might be
In
as
the
easy as having an export that provides them, right?
Pardon
so
me?
in the system-wide ones, do the users in different workspaces compete for the same concurrency level?
Yes, and I think Mike's previous suggestion of adding the workspace as input to the shuffling makes sense.
Well, yeah, so I'm still trying to think through the two-layer approach. So in the two-layer approach, in the outer APF, remember APF itself has kind of two layers, right? There's this isolation into a collection of priority levels and then fairness within each priority level. In the outer APF, is there any meaning to a collection of priority levels, or would we only be doing fairness between workspaces?
If we can detect like loopback traffic from the virtual API server, stuff like that, I think that could be a privileged priority class. Or from the caching server.
So something we haven't talked about is in APF, there is, it starts with configurable classification, and actually some priority levels don't queue or reject. They just pass things through without any further control. So that's already kind of a feature of APF in that the configuration, you can write a flow schema that says these requests go to that priority level, and that priority level can say pass it through without any control.
Yeah, so that's basically what we want for all the system level things. I mean, not necessarily all of them, but majority of our controllers, the loopback clients and whatnot. If we need to divide them into categories, we can, but those need to take priority generally over any other client.
Yeah, and in the default configuration for APF, the admin clients get classified, or their requests get classified to a priority level that passes things. It's called exempt,
Yeah.
that passes things through without control.
There's also a feature, I guess, where like in a production deployment of KCP, you provide users, different payment tiers or whatever, and that allows their workspaces to have more or less priority.
Okay, but remember, priority is actually only an aspirational word. We don't actually have priority. We have these
Don't
isolated
charge them as
currency
much for them.
pools. Well, but it really is not priority. Okay. There was originally some thought that we could have a sense of priority, but we don't. Even with borrowing, that's not prioritized.
But more shares, right, Steve, is what you
Right. Yeah. I'm just saying like there is like the further meaning of priority classes at the system level could be some sort of quality of service.
Well, I'm again, I'm still struggling with this. If we do a two-layer approach, and we have an APF that is just, treating each workspace as a unit, okay? Does it make sense to both have priority levels and flow schemas? Or does it make sense to only have the fairness, which is what the flow schemas give, right? Is there any meaningful sense of dividing workspaces into different concurrency pools?
I guess I'm saying yes, because I think like first, I could consider like two canonical users of KCP that I think we've had in mind. One is like the service provider, right? So I'm exporting certificates and I'm running Cert Manager in my workspace. That workspace is going to have a lot of traffic, and that traffic is critical to the functioning of like their service.
Okay.
And that could be higher priority class than some random user installing
Right.
auto.
Except again, we don't have higher priority. We just have different pools, which can be given more or less concurrency. Okay, so
Right.
you answered in the affirmative. There is a sense of um, a kind of a use case for grouping workspaces into different concurrency pools. And then within each concurrency pool, we would just do fairness amongst the workspaces.
Yeah, I think that makes sense as a first
All right, we're out
approximation,
of
right? Because
time.
that's analogous to namespaces, the way that they're handled.
Okay, we're out of time. I'll update the document according to our discussion and think about this multi-layer, two-layer approach some more. And I guess we'll talk again later.
Awesome.
Great.
Thanks for your
Thanks.
time.
All right, thanks.
Thank
Bye.
you.